Hello, my name is Adam Moss.
And my name is Sam Nowak.
We are from the Center for Health Enhancement Systems Studies in Industrial and Systems Engineering. Welcome to our talk on engineering a human-in-the-loop tick identification system for a research study mobile app called the Tick app. Now, to begin, you might be asking yourself, what kind of ticks are we talking about? In this presentation, we won't be talking about clocks or marking a checkbox. Instead, we're talking about everyone's favorite parasitic arachnid, the tick. For those not familiar with ticks, ticks live in woods, parks, in the grass, and sometimes even in yards. They feed on the blood of mammals, birds, and even amphibians or reptiles to grow and survive. Ticks can range in size throughout their life cycles. Nymphs may be as small as the tip of a needle, as shown to the right, or longer than a quarter inch. Since ticks feed on blood, they can transmit blood-borne pathogens that lead to potentially debilitating diseases like Lyme disease, anaplasmosis, and babiosis. So, with all the problems that ticks can cause, researchers set out to track human tick exposure and to inform the public about ticks and tick prevention. In this talk, we'll give you an overview of the Tick app, a project developed to help researchers track human tick exposure. The tick identification we use within the app to identify different species of ticks, how we integrated AI into this identification system, and some lessons that we learned along the way. And finally, some areas of opportunity. By the end, we hope that you'll be able to take away two things. First, that you'll remember that there's an app for reporting ticks next time you're out hiking. And second, you'll learn one approach taken for integrating AI models into a fully manual system. But first, let's talk a little bit about the Tick app. The Tick app is a citizen science project designed to study human behavior, tick exposure, and the risk of Lyme disease. Researchers had several goals in mind, but primarily they wanted to learn what level of knowledge people have about ticks and tick prevention. They also wanted to learn when and where are people being exposed to ticks. The project has been a joint effort between the Northeast and the Midwest Regional Centers for Excellence in Vector-Borne Diseases. Sam and I, along with a few other developers at Chess, built the app and provide ongoing support for it. The Tick app is available as a mobile app or on the web for free. It was based on a prototype called GeoQuestion and was first released in 2018, making it the first tick research-focused app in the United States. As of May 2024, it has nearly 24,000 users, and over 1,000 were already active this year. On the right is a picture of the homepage. The front end was written in Ionic, a JavaScript framework that allows developers to write the code once and deploy it to iOS, Android, and the browser. The backend API is built using PHP and MySQL as part of a LAMP stack in UW-Madison's campus cloud infrastructure hosting environment. As mentioned, the app was designed to study human behavior and tick encounters, and each of its features were developed to help with this. First, the app contains a library of information to educate users about ticks, tick prevention, and how to remove ticks. Users can also see what level of tick activity there is in their area. In addition to this, we've developed several tools to help researchers learn more about the users and their potential risk of tick exposure. Today, we will be taking a closer look at two of these features, the daily log and report a tick. The daily log is a daily survey that collects information on the user's activity on a given day, any tick encounters they had that day, and any protective measures used to prevent tick bites. The report a tick feature is meant to be a real-time survey that collects information about where and when a tick was encountered. Both the daily log and report a tick features let users upload pictures of ticks that they've encountered in what we will call the tick identification system. This system was developed with two goals in mind. First, to help participants find out if they had been bitten by a disease-carrying tick. And second, to help researchers determine where and when people are finding ticks and use that information to tailor interventions to help with tick prevention. We used these goals as we designed the system and developed the following flowchart. First, a user takes a picture of a tick they've encountered and uses the app to send that picture to researchers. Researchers then identify what type of tick was encountered and notify the user with educational information about what to watch out for if the tick has bitten someone. Finally, researchers could use the aggregated data to find patterns from all of the tick encounters on the app. For example, this graph was taken from Kosh 2023. It shows a distribution of submitted tick reports from the app between 2019 and 2021, with the heaviest number of submissions being in Wisconsin, Michigan, and parts of New England. Researchers could take this information and learn more about these users, as well as disseminate material to educate people about ticks in these areas. Armed with the flowchart, we developed and launched the first version of the tick identification system in 2018. In this version, after a participant submitted a tick report, a Python script ran daily on a chess workstation to download the reports from the tick app server and assign them identifiers, then upload them to box.com. Researchers ran another daily script to download the reports from Box and store them in their own system. Human reviewers would use the researcher's system to identify the ticks in the reports and send an email to the users with information about the type of tick that they had encountered and things to watch out for if they were bitten. This worked well enough, but there were a few issues that we noticed after using it for a while. First, there was no way for participants to see what tick reports they submitted. And second, some of the pictures weren't in focus or didn't show a tick clearly. We made occasional updates to the daily log and reported tick questions, but the first major update to the tick identification system came in 2021. In this version, we added some instructions, as can be seen on the right. These were designed to encourage participants to take pictures that clearly showed distinct parts of the tick that would be helpful for identification. We also added a page where users could see some basic information about the tick reports they had submitted. This page shows when ticks were reported and the identifiers we assigned them. At the time, this was the only information we could easily access about the submitted tick reports. As for the rest of the process, that pretty much stayed the same. Scripts were still used to upload and download reports, and human reviewers still had to manually identify and email users. Then, at the beginning of 2023, the team met to discuss updates to the tick identification system. We created 2 goals for the next version. First, a student researcher from UW-Madison had recently released a deep learning AI model called TickIDNet, and the team was interested in trying to integrate it into the system to see how well it could do at automatically identifying ticks. We also wanted to reduce the amount of work that human reviewers had to do. To give you an idea of what it was like, for each report, reviewers had to find that report in one system, then find the tick picture in another system, and finally save the review in yet another system. And then after all of that, they still had to email the user. So you can imagine that the turnaround time could take multiple days, especially during peak times when people were outdoors, like during summer. So anything we could do to improve that would be greatly appreciated by reviewers and app users alike.
So, as part of this next phase, Adam and I took those goals and started integrating AI into the tick identification system in an attempt to streamline the review process. We released version 3 in May 2023 and made the following changes to the tick identification system. First, since an ongoing issue had been getting clear images of ticks, we took a step towards improving that by creating a preview screen when taking a picture of the tick, and to subtly encourage users to align the tick within a circular overlay, as shown in the screenshot to the right. Secondly, to reduce the work that researchers had to do, we moved the entire review process into the tick app. Now reviewers only had to log into the tick app to complete their reviews. We also updated the tick reports page so users had more beneficial information about each tick they reported. Along with this, we added notifications to let reviewers know if there are any new reports waiting to be completed, and to let users know when their tick reports were reviewed. Finally, we added the TickIDNet deep learning model to start testing how well it worked, and to aid reviewers in identifying ticks in their reports. So what is TickIDNet? TickIDNet is a deep learning convolutional neural network developed by a student researcher at UW-Madison. He used 10,000 images taken from the tick app and 2 other websites to train the model to classify pictures into one of 3 tick species that are prevalent in the Midwest and Northeast: the deer tick, the American dog tick, and the Lone Star tick. On a test set of 1,100 real-world images, the model achieved an 88% accuracy. However, even though the model worked great on images of ticks, it does have some trouble when an image doesn't contain a tick. Anecdotally, one researcher said that it once classified an elephant as a tick. So knowing that weakness, we knew that we'd need our human reviewers to double-check TickIDNet's work. Thus, we built the Tick Report Review Form as a human-in-the-loop system. In the context of machine learning, human-in-the-loop refers to including humans to help refine an AI model or the results of a model. For the tick identification system, what that means is, after a user submits a tick report, the report goes into a pending state. TickIDNet, running in the background on a server, predicts what kind of tick is in the image. If its confidence for a particular species is over 75%, then the review form autofills with the predicted species. Reviewers can then come in later and adjust TickIDNet's suggestion and release the finalized review when it's ready. This empowers researchers to have both increased speed and accuracy in their reporting, while giving the human the ability to weed out anomalies and make up for any potential shortcomings of the machine learning model. So it's a win-win, right? Kind of. In early 2024, we met again because there seemed to be a problem. Within the tick app, TickIDNet only seemed to achieve about a 60% accuracy, even though it was near 88% on real-world images in the paper. So we tried to figure out why that was happening. And after looking at the data, we found it to be mostly caused by how the images were cropped and fed into TickIDNet. TickIDNet only takes in images that are 224 by 224 pixels. Since most pictures are higher resolution than that, we came up with a simple algorithm. Since we had the camera overlay, we hoped that people were aligning the ticks within the overlay's circle and simply cropped out the center of each picture and fed that into TickIDNet. But whether due to the tick crawling around or the amount of precision needed to place a tick within that little circle, the cropped images were often missing the tick in an otherwise acceptable tick picture, like the screenshot on the right. So we looked around for smarter algorithms and found YOLO. YOLO is an acronym for You Only Look Once. It is a machine learning model that specializes in object detection and image segmentation. It is often used to pre-process images for training other models and prepare images for classification. So the team proposed putting YOLO into version 4 of the tick identification system, and having YOLO find any ticks within an image, no matter where they are, and crop them so they can be fed into TickIDNet for more accurate results. But since YOLO was a machine learning model, there was still a lot that went into getting it ready to detect ticks. In order to train YOLO to pick out ticks from an image, it needs lots of examples of images with bounding boxes drawn around each tick. We utilized an archive of tick images from the tick app and started annotating them for use in the training of the model. To speed up annotation, we used a website called RoboFlow to share this task with 3 reviewers. This step required uploading about 1,600 tick images to the website and drawing bounding boxes around each tick present in the images. Once the 10-hour manual process was completed, we exported the object classification and coordinates of the ticks in each image in the file format usable by YOLO. The training of our latest YOLO model, which involved successive splitting of the training images into validation and training sets, took around 3 days to complete. Afterward, we took our trained model and added it into the tick identification system. We are now waiting to see how well YOLO helps TickIDNet this year. However, we already know there are a few issues that we will need to address, particularly with YOLO. The first is our assumption that there is only 1 tick to review per tick report. In practice, users sometimes submit as many as a dozen ticks in one picture. Currently, we handle that by selecting the first tick detected by YOLO for the report, but ideally future versions of the app will support multiple ticks, each being identified and displayed to the user on the tick report dashboard. The second issue with our model is the presence of commonly recurring objects in our training data, such as tweezers, pencils, hands, or coins, which are used by users to restrain a tick, or to provide a sense of scale. However, the pervasiveness of these objects leads our model to associate them with the ticks they are placed right alongside in the image. Future trainings of the model might use so-called null images of these common objects to train them out of the image detection, but we are hopeful and excited to see what happens. There was a lot of new territory we explored as a team, and that has yielded some considerations for our future projects and our next steps in the TICAP. Of all the various issues and triumphs over the years, we have distilled them into 3 lessons. Expect your pipeline to change and prepare for that eventuality. Build each component without dependence on one another to allow for modularity and efficient division of labor. And create system resilience by accounting for server downtime, knowledge loss, and user-facing edge cases. Going into the development, we knew the AI-powered tick identification system was a prototype, so it was important to make sure each new additional feature could function regardless of changes to other components. This enabled us to slot in new features as the need arose, without having to rework satisfactory performing components. In a prototype, deciding on the user experience may be more important than how the data is structured, and the final schema may not be decided for several iterations. Knowing that we might be changing any part of the pipeline at any time, we stored some of the model and classification data without a rigid schema. Typically, schemaless structures have some negatives and can take a hit in performance, but they make up for that with their flexibility. Now, if we want to change YOLO or TickIDNet, we can do that. We could remove them, replace them, or even add another model to the mix without dramatically changing the database. Eventually, as the prototype matures, and if we start seeing performance impacts, we will formalize the schema. As a smaller team, we often develop the full stack for our projects, but for the TICAP, we had the opportunity to divide the workload in a more manageable and thus faster way. Each contributor worked within their expertise, whether that be developing the machine learning identification models, developing the custom camera overlay application and the user experience for reviewing tick reports, or coordinating the pipeline in its entirety so as to make the process as seamless as possible. Complications naturally arise during projects, so each contributor being able to focus on one particular element greatly increased the quality and efficiency. Having clear expectations for inputs and outputs enabled each component to be pushed to test version as they were finished, speeding up our rollout to production. To facilitate the joining of the entire pipeline, documentation on each component saves considerable time and should be strived for even if in reality it is never 100% complete. Keeping the user experience consistent with each new version is important for mitigating data loss and limiting user frustration. Something we overlooked when doing a server migration caused our automated classification algorithm to go down, as we had not accounted for having certain packages being installed on the new server. But even though TickIDNet was down, users and reviewers could still submit and review tick reports. Another concern was the knowledge loss, either through passage of time over the course of the project's 6-year lifetime or from staffing changes. The original developer of TickIDNet was unavailable for our later changes, which could have hampered our ability to improve on our pipeline. There was also concern of shifting developers to the project that hadn't worked with it before, so being able to weather these changes improved the resiliency of the project. The through line that aided in each of these aspects was documentation. Because this was a long-term project, it was important to adhere to the sometimes easier said than done best practice of documentation. By documenting each section of the pipeline, we were able to more easily onboard developers switching to the project, and to aid the imperfect memories of developers over the 6 years of off-and-on development. Knowledge loss is a big concern in any project, and documentation has saved us a lot of headaches throughout.
The tick identification system and the tick app as a whole is always a work in progress, but we wanted to talk a little bit about where we think it is headed.
After we officially launch our new YOLO plus TickIDNet pipeline this spring, we'll be keeping track of how well YOLO performs at cropping the images, and what potential problems we run into when combining YOLO with TickIDNet. We'll also be very interested in seeing how well TickIDNet performs with the newly cropped images. Additionally, we know that we'll always be working to improve the user experience for users and reviewers. One project we imagine is moving YOLO from the server to the app and making use of live video detection to further enhance the accuracy of our AI models. Though, we know this will be a large undertaking with many performance considerations. The intention behind this will be to provide instant feedback on image quality, so we can try to mitigate cases where the image is blurry or the lighting obscures the tick. In addition, multiple snapshots could be taken from the video, aiding in the identification process. We'll also be working to improve each of the components of the system. Some potential projects include improving each of the AI models, trying out different AI models, and building the tick reports to handle multiple images. It is exciting to think of all the ways we can improve just this small piece of the app.
But it also makes us think of the bigger picture. Every day it seems like something new is happening in the field of AI and machine learning, and organizations are rushing to create new AI-powered systems. And just like everyone else, we're excited to see what AI can do to help people. But as we go down the road of automatically identifying tick species in pictures of ticks, we wonder, even if a model is close to 100% accurate, or 88% in terms of tick ID net, should we ever really remove the human from the loop? And we thought about this. And the short answer right now is, we don't really know. But maybe it depends on the answers to a few follow-up questions. First, and most important, how much risk is there if the system is wrong? What kind of trouble could a fully autonomous system cause? Is it a dystopian future level of scary? Or is it the kind of risk where your stock image of a tick has 2 extra legs? Second, how much time, effort, and money goes into having the human in the loop system? If it's a little, maybe it's not so bad to have them keep tabs on things if the AI is like 99% accurate. If it's a lot, and there isn't a lot of risk, maybe it's time to find ways to cut the humans out. Or maybe there is some way to merge the two and have the AI take care of the easy things and let the humans take care of the hard things. Lastly, how much time, effort, and money goes into supporting and maintaining a human-in-the-loop system or a fully autonomous one? Keeping that human in the loop can solve a lot of problems and make lives easier. However, keeping humans around also requires that you put resources towards maintaining 2 systems, one for the humans and one for the machines. You also have the added complexity of training these humans to use the system and the problems that arise when humans even get it wrong. But on the flip side, having a fully autonomous system could be just as much of a maintenance burden, if not more. What happens when the fully autonomous system needs to be updated, or it doesn't scale quite as nicely as you'd like? These systems often require people with specialized knowledge to maintain them. And just like every other software system out there, AI models usually require updates and all the headaches that go along with those. So it depends. Just like most things in life, there are pros and cons with everything. It really depends on your situation and what resources you have available to you when you try to answer these questions. And as for us, well, we'll see where the tick app and tick identification system is in another 6 years, and maybe we'll have a better answer then.
Thank you. We appreciate getting a chance to share a little bit about the tick app with you. We hope that you learned a bit about ticks and how we engineered a human-in-the-loop tick identification system. We also hope that next time you are out hiking that you will remember the tick app and will help science by reporting any ticks you find. And please don't forget to check for ticks. It's one of the fastest and easiest ways to prevent tick bites and tick-transmitted diseases. If you're interested in learning more about anything we talked about, please check out some of these resources or check out the description below for how to contact us with questions.